First of all, how do we distinguish and understand one end or two end, and let it be applied to actual maintenance? Choose a model at will, and find the difference in the process of speaking. I suggest you use a notebook to draw it down to deepen your memory and compare. First we find the first end. The first end starts from the direct power supply of the battery. The battery is connected by an inline socket. So it is the positive terminal of the in-cell connector of the battery. Open the input and see the physical picture of the 6 series. In the picture, the battery holder looks like this. I use a paintbrush to mark the positive terminal of the battery is here. Take the drawing as an example. You will find the red FD2502 and TP2513 are TP test points. Including U underline HBS underline IF high frequency switch. Inductor side. 2-stage power amplifier. I now summarize the 6 series. And including these components. Capacitor, chip. Charging IC. MOS 9-pin tube. These products, the bright red area, are the first end products. It is best to write it in a notebook and use it flexibly. The first end can also be called B+ power supply. There are inductors, 2-stage power amplifier, HBS underline IF high frequency switch, charging IC, 9-pin MOSFET, capacitors. These components. The first end contains many components. For a detailed look, we have to count. We want to count the red zone, HBS, inductor, 2-stage power amplifier. If you are not familiar with Chinese and English, you have to check it. The next one includes speakers, vibration IC, including these, C2550, C2549, C2575, etc., and the inductance here is the product of the first end. Because these have not passed through the next IC, they have voltage when they are powered on. Now you can measure the voltage in the red area as long as you switch on the regulated power supply or battery. If the chip is covered, it cannot be detected, usually exposed, like capacitors, inductors, pins, etc. Including this row of bright red areas, the voltage can be measured. It means what it contains. We first summarize what it contains: a first chip in addition, components with a capacitor outside, and an inductor. Some people pass through these inductors. This pin will also lead to the speaker. This is the very speaker. I have encountered a repair case about this kind of power on meter. I almost gave up in the end. And it was fixed later. Finally, it was found that this inductance was caused by the inductance. The two sides were connected to C1648. I connected the tin in series and then caused a short circuit. The entire motherboard that should be removed was removed because it caused. Said this case is to hope that you will not ignore these places, especially the inductance category. There will also be products of the second stage on the other pin of its rear stage. It must be known that it is also a product belonging to the first end, which will also cause power leakage. After the first end, find the second end, and the second end is through the charging IC. So we just need to find the charging IC. Find charge IC by distribution components. Critical. Before the XS Max series, there will always be MOS next to it. This is our charging IC, which is very important. There are so many points. We need to enter our schematic diagram. If you are not familiar with the schematics, let's briefly explain. To back afraid, we will take the appropriate course part of schematics or point bitmap. Let you specialize in the knowledge of drawings. First, use their name PP_BAT_VCC to identify the first end. It passes through the 9-pin MOS, which is the direction of the current. From now on, it is still BAT, which is the first end. After passing, it passes through the row of pins A2, A3, B1, B2, B3. After reaching the top of the conversion, their names have changed. The name becomes PP_VCC_main. This is a product of changing from one end to two end. In addition to it, we said that there are two. One is a charging IC, the other is a 9-pin tube. You see that BAT is written in it. It is still the first end of the power supply. The battery comes directly in and goes out from above. Be sure to remember that all electricity comes in and out. Go this way through it. You will find that when we reduced it, it also went away PP_VCC_main. It also becomes a product from end 1 to end 2. Just like a charging IC. This is their bridge function. Let us take a look at the direction of the current in a separate division. We have to draw it. First, these two lines go from the battery. They are all a process from end 1 to end 2. Strictly speaking, C1, C2, and C3 belong to level 1 products. The following A2, A3, B1, B2, and B3 belong to level 2 products. This is a bridge. A lot of people want to ask a question. Are the charging IC and 9-pin MOSFET 1 or 2 terminals? In fact, I'll give you an example so everyone can understand. Since they are bridges, such a bridge spans two areas. One side is in the A city. The other side is in B city. The west of the bridge is in B city. The east of the bridge is in the A city. Does it belong to the A city or B city? I can't answer this question exactly, because both sides contain. It belongs to one end and the second end, but does not say which end it belongs to. But there will be problems at both ends, which will cause problems with the charging IC. If China or the United States catches fire, it will affect the other end. They are shared. Next, find out the A2 and A3 pins. Find the pins A2 and A3, and you will instantly change the red area. It is no longer the product of those speakers just now. Take out your notebook and take notes. Including small power supply, also called PMIC. Small power supply is also called baseband power supply, including C3216, C3220, C3217, C3219, even includes a buffer U17018. But in the actual process, there is no such thing. This is the main power source. Why is it called the main power source? Because all the electricity of the charging IC is basically irrigated on the main power supply, including our NFC chip, including filter capacitor, including Wi-Fi module, C5202, etc. Why are they easy to damage? I have a question for you. People often repair this capacitor. Why is it easy to damage? The second one is big audio. Step by step to CU1501 display IC. Look at the fingerprint boost IC again here. U1503 fingerprint boost IC, including flash IC. You have to write these names in your notebook. Some people may say that I don't recognize the picture here. It doesn't matter, but remember the name I said, including this inductor, including the backlight control IC. The backlight control IC refers to a chip. Many people may ignore this. I have also encountered is to fix the fingerprint and then lead to power on max current, including C2301 and U2301 are also voltage conversion tubes. They are all second-end products. I have already talked more carefully, including our power amplifier power supply tube. Including our capacitors and inductors, are products of the second end. Everyone should write it in the notebook. You can compare them. You will find that there are different chips on end 1 and end 2. We will put it together later. We must write it down for comparison. Some people say that they can't find the third end in the 6th generation. I have already said that there is a third end only after the 7th generation. Now I will talk about 6th second again. Let you consolidate the knowledge just now. These are your must-have skills. Still enter from the product battery interface at the first end. Write it down the same. The first end of 6th second. Everyone will find a problem. We look at the entire motherboard except for the battery interface. It gives power to the charging IC, U2300 and 9-pin MOS tube. That is 2 chips plus 6 electrical capacitance. This is the first end of 6th second. To sum up, in the 6th generation, there are also high-frequency switches, 2-stage amplifiers, speakers, and vibration. They all belong to the first end. Why is there no such thing in 6th second? Is a concept we mentioned earlier. Because the charging IC did not previously protect the speaker of these things. Now for the mobile phone to upgrade safety. So put these behind the charging IC to protect it. Let us open the drawings of 6-second and tell everyone about each of the above. Everyone can use this to make a self-summary. Still turn on the Q-tube or circuit. You will find that it is still PP_BAT_VCC 9-pin tube, still A2, A3, B1, B2, B3. The pin position has not changed much. Still convert PP_VCC_main, which means it is similar to the 6th generation system. Still a bridge. Let us click and see the lower part of the drawing. In my frame of blue area here, it is PP_VCC_main. That is, the circuit in the red area represents the second end. Let us take a look at the second end. You have to take notes. First, including these capacitors, 2-stage power amplifiers, and these resistors, including small power supply, speaker vibration IC, main power supply, display power supply IC. There are also NFC, big audio, fingerprint boost, Wi-Fi module. Just write it down. You don't need to mark it. Including fingerprint boost tube, light control IC, flash IC, 3D Touch ID conversion tube. There are intermediate frequency power amplifiers, low frequency power amplifiers. The low-frequency power amplifier passes through the bridge of the inductor, and the inductor is the bridge. It is also a place that is easily overlooked in the repair of water-incoming mobile phones. Then I will give you a circle. After passing this bridge, the inductance is transferred to this chip. Some people will ignore it after dismantling it, but it didn't click here. Just click here to replace it. Although the power amplifier is rarely broken, it can also be broken, including power amplifier IC. This is where the 6-second second-end inductance is in the whole mobile phone motherboard. Be sure to list these, and we will compare them later. This is the second end. Next, let us look at iPhone 7. iPhone 7 is still like this. Everyone should be familiar with it now. Still go from the battery interface and then check what it contains. The first C2244 capacitors plus TP test points. After switching, you will find C2108. Then charging the IC and 9-pin MOSFET. I will draw these two areas. Entering this area, I still use the schematic diagram. I try to explain each step in detail so that you can consolidate your knowledge. Q2101 is still the conversion from the battery voltage through the Q-tube. After conversion, it becomes the first end PP_VDD_Mn. At present we found that it is a structure like this. We click here to see the second-end products of the 7th generation. The 7th generation is similar to the 6S. It also charges IC 5 capacitors. Then there is display IC, backlight control, if it is 7P. There are 2 backlight controls IC. You understand now. You write what I said. You will be easy to recognize when we explain the specific circuit later. After entering, there is vibration IC and speakers. Both the IC U3402 and the U3502 chip. There is also a small power supply BBPMU. Next, there is no big audio. It is available in 6 second and 7. There is also U2301, the main power supply. Includes Wi-Fi module. Let's switch again to see if there is any other place. There is also an integrated inductor, which may be different from 6 second. There is also OPOET_IF power amplifier IC. Look at the red dot area. Next, let us look at the speakers. Here U3301. There are also NFC power supply tubes. NFC load power supply tubes. These must be memorized and listed in a table. And don't forget about this M2600 flash IC. We basically recorded the second-end products of the 7th generation. Now we start looking for the third end. For unfamiliar motherboards, it may be difficult to find. I'll teach you the most direct and simple way to find. A set to know the voltage of the third terminal is converted by the second end. We certainly first from the second end of the search for the name of the third terminal because their names are slightly different. We keep looking from the second end. The place you click through the schematic is the product of the second end. There is a boost conversion here. From here, PP_VDD_boost can know that this is the name of the third terminal. So the second end is converted to the third end. Then here is the bridge from the second end to the third end. Here to tell you a point of knowledge is about the essence of the bridge and the two systems. 9-pin MOS tube and charging IC belong to the IC series, but you will find that when VDD_main is less than 3.4 V, the boost chip will be boosted to be the same as the main power supply after 3.4 V. In other words, it is not in a boost state at any time. If the voltage is too low, it will boost the voltage. Normally, the second terminal and the third terminal have the same voltage. Unless it is lower than 3.4 V, it will switch to boost the voltage. In fact, the first terminal is also equal to the second terminal and the voltage at the third terminal. Their voltages are basically the same because they will be available as soon as they are buckled. The voltage must be the same. Let's take a look at where the chips included in the third end of the 7th generation, B3 and B4. Take a look at where U2301 is. Right here, B3 and B4. Use paper to write down what are the third level or third end of the 7th generation. Main power supply. Big audio. U3101 audio IC. There is also a small power supply and a fingerprint boost IC. The third side include products are relatively small. It is the main power supply, big audio, small power supply, baseband power supply, fingerprint boost IC. Now you can read the notebook you recorded. You will slowly discover and find some patterns. I saw it here for the 7th generation. Now let us talk about the 8th generation. Because the 8th generation does not have a schematic diagram, it can only be found through 8P. First, the battery interface has changed. It uses fast charging. Here, you will find that there are still C3290 or C3352. Do not say components. Still will have charging IC. By the 8th generation, the charging IC has been upgraded. Unlike the 6th and 7th generations, first, the shape has changed. Let's take a look at its physical map. It is already off square. Some people will ask whether its chip is universal. Its shape is not universal anymore. Certainly not universal. Just like your shoes. One is 38 shoes and size 40 feet. It must not be worn. Everyone must know that it has undergone a big change. It still only leads to the charging IC and the 9-pin tube. So far, its law has not changed. Through past experience, I clicked on this area and it is still the second end. Now take out your notebook to sum up the rules. Light control 1. Backlight IC. I want to talk about these capacitors, including the backlight control 2. There is no difference between backlight control 1 and backlight control 2. Just 2x. There was only one light control in the previous 6, 2nd and 7 generations. Let us talk more about the lighting control circuit course later. It has 2 chips. That is, both chips will cause the same phenomenon. The second one, this is U5600 display power supply IC. Everyone should take notes, including this vibration IC. Write it down. I want to talk about these charging X and 9-pin tubes. The speaker IC is also called the bottom speaker IC. Next is the fast charging IC, also called wireless charging IC. Some students may notice that there is an additional wireless charging IC here. In front of the model is not the. Let us not talk about some other filter capacitors and baseband power. Here, then the main power supply must be available. Some people don't know if they don't draw. Including front earpiece IC, which is also a kind of speaker. There is also a wireless module WLAN_W. Everyone should be able to find this module here. There are also several capacitors. Everyone should pay attention. Power up the max current and power up the high current. These are prone to problems. Very much. Just one deduction. Quite a profitable job. Here is the power amplifier IC. Remember to take notes when I say. Let us not talk about these capacitors. These 2 capacitors. And these are integrated inductors. This is the 8th connector. Basically we can't see it. Next is the camera power supply IC, which is a new thing again. There are also NFC power supply tube and NFC. Then this is our second end. And flash M4100. We slowly began to be able to summarize the. There is also a U3100 tube here. Also it is a product of our second end. After the summary, you will find that there are more wireless charging ICs and camera power supply tubes. Everything else is similar to what I said before. The 8th generation also has a third end, which is similar to the 7th generation. I click on the 8P model to enter it. There is still boost. Still use PP_VDD_main to convert. And then to PP_VDD_boost. It is also the third end. Still B3, B4. And the pins are not changed. Take notes. There are also large audio IC, main power supply, baseband power supply. Then there will be these functions in 8P. There are a lot of things in it. High frequency power amplifier, low frequency power amplifier and ultra high frequency power amplifier. These pins are all here. They also belong to the third end. And 3D touch power supply U5890, which is also the third end. Including camera power supply. It is also like a bridge. It not only needs the main power supply. It's like people need to eat vegetables if they want to eat a main power supply plus a third end. So it also includes the power supply of the camera. So be sure to take notes on it. Remember that these things we are looking for are all the experiences we have collected. This is our 8 series. Let us look at the iPhone X. Next, I will find 2 more models at most. Otherwise the time will be too long. Let us talk about the iPhone X. Because its mobile phone motherboard has begun to change. What will happen to it? iPhone X has a dual-layer motherboard. Does the double-layer motherboard conform to the principal system? This is a key point. Still find the battery interface. There are still charging IC and 9-pin MOS tube. Up to now, it also conforms to the principle mentioned before. It will have LS points here, which is the middle frame point. The double-layer motherboard has a middle frame point. After arriving here, the battery will be removed from the upper layer. It is communicated through these 2 points and must be posted on the entire motherboard. Switch again through the interface including through the upper layer because the battery interface is on the upper layer, so it conducts to the lower layer in this case. Fold down like stacking our hats. and conduct electricity down. There are a few capacitors on the first end, plus the middle frame test point, plus the charging IC and 9-pin MOSFET. We already have the above experience. So let's look at the second end to take notes. First, I say you write flash 1, flash 2. So when it comes to iPhone X, it becomes 2 flashes. In fact, it has changed from the 8 series. But now they are all together. Flash 2 plus camera power supply. Next is the infrared power supply. And there are new chips. It is two-phase supply. This is a new chip. Next, U3100 is the third end conversion tube. And 8P is also similar. Including main power U270 and middle frame test point. These must be explained clearly to you. Because sometimes the iPhone X double-layer motherboard is in the process of power on and leakage. We must distinguish between the upper and lower levels. This is very important because some people will not leak electricity after they are removed, but they will leak as soon as they are fitted. Many times go down through this middle frame test point. Many people want to get involved in this situation. Everyone must know. Then there are NFC and NFC power supply. Wireless charging IC. This is no stranger, because it is available in the 8th generation. There are also speakers and vibration IC. Front earpiece. Including lower speaker, small power supply, bassband power supply, power amplifier power supply. This is for notes. If you want to remember, you can't be lazy. Power supply and Wi-Fi module. As long as you take notes, you will find that you have talked about it before. These are the products of the second end of the iPhone X. You need to write it down and summarize. I need students to operate these things on site. I did this summary for you on the internet. Because I take you away. You will never grow up. You have to learn to handle it yourself. Because I can't explain every new model. Because these are very basic. What I teach you is the method. There is also a voltage conversion tube U2600, a vacant tube. This is very rare, but it can also cause. This U6100 is also a conversion tube. Under normal circumstances, if there is a short circuit at the second end, we will test the J5700 seat. It also the display connector and measure it on this. It is more intuitive and does not require layering because the others are in the middle frame or in the shield. It is not easy to measure. So this seat is the best measurement location. And you can know if there is a short circuit. There are two more critical ones, vibration IC and touch power supply IC. iPhone X vibration IC is here U5100. Many people ask me where is the touch IC. It's all here. This is a touch powered IC. Here appeared the new IC name of. Each generation of models has changed step by step, and this is where Apple is upgrading. It has a lot of changes in it. Let us summarize what's more, what's missing, and what's changed. The position of the third end of iPhone X is U3100. iPhone X and 8th generation are universal, basically the same. Still use the second end, PP_VDD_main to switch to the third end. It's basically the same. You can take a look at the pins of B3 and B4. I want to write to you one by one later. iPhone X has more camera power supply IC and infrared power supply IC. Infrared power supply to this part of the face, including big audio. Main power. Post point. This post will also have a power on leakage problem, which is easy to be ignored. In the double-layer motherboard, many people can't check it. It is the distinction between the upper and lower layers. There are also small power supplies, UHF power amplifiers, low-frequency power amplifiers, high-frequency power amplifiers. I am here to draw it for you. These are the third end. And the most important is CPL. CPL is our coupler, signal coupling, that is, signal transmission. In fact, it has the same function as the antenna switch. And we will talk about it in the signal circuit course later. The above is a summary again. Next we talk about the next type. The second structure of the power supply structure changes from XS Max. From 6th to 6th, 2nd to 7th generation, 8th generation X. These basically have not changed. What changes? I will give you a review of the previous knowledge. Pass through the charging IC through the battery interface, always accompanied by a 9-pin MOS tube. After being here, we will switch to level 2, which is the only one, since XS Max has changed. The circuit has become more secure. Not only this one circuit has changed, but many circuits have changed. From the core board, the battery interface has not changed. Only the size of the battery interface has changed. What everyone should consider here is the battery SBAT. When we talk about charging, we will talk about the problems with its detection circuit. Now find its power supply first. Just now I used the point method to find. Now I use this method to find. Here U3300 directly reaches the charging IC. Write it down now, and summarize it later. There are two voltage regulator tubes of D3300 and D3301, which are more suitable to be called protection tubes. They are rarely damaged. Most of the time they are directly replaced. Because it is a pure voltage. I don't recommend you to short circuit it. Don't short circuit. What you see are two voltage regulator tubes, which are actually two glass tubes integrated into one, rarely damaged. To the test point of the middle frame. Click again later. Then these can be ignored. We will not talk about the comparison table. When it comes to the charging IC, it's nothing. Let us look at the physical map and look at the XS Max models step by step. When it comes to the charging IC, it is necessary to consider its detection resistance. If there is a problem with the detection resistance, the phone will not turn on. What I am telling you here is a detection voltage, unable to boot because of unstable battery voltage. There will even be such a problem. The battery is not installed soon after the logo is turned on. This is the phenomenon of the current when the charger is plugged in and the battery is not installed. Especially this resistance will affect the change of charging properties. A phenomenon that affects the stability of the charging current is small or fluctuates greatly. This resistance will also cause the phenomenon of virtual welding, although very few in the repair process, but also encountered. Then comes the electrical change of the charging IC. There is no 9-pin MOSFET anymore, because the 9-pin MOSFET is protective. It is integrated in the charging IC. Then it has to have some protection circuits. The protection circuit has changed. Look here. We all know it is bad from the battery. Then go to here through the charging IC. Follow this line all the way to Yangtze. The charging chip opens the class power boot 1. Here is the key. This is the detection circuit after XS Max. In fact, everyone will be familiar with this name. You will find that PP_VDD_main is the second end. Although the name in front of XS Max is PP_VDD_main as an embellishment, but it has the suffix of Yangtze, which means it is not a complete second end. We also can be called quasi two-stage front end or both ends. This is a new concept, or someone else hasn't told you about it yet. But I will mention it to you now, because the second end only has PP_VDD_main without suffix, but this one has Yangtze suffix, so-called quasi-two-end or two-end pre-stage. The front pole is divided into this detection resistor, larger in Android system. There are black, white, big R3303, but the number is not large. White choose a small number. Large resistors will consume power, and the protection resistors are easily damaged. Because of the limited current of resistance, a large resistance can easily block a lot of current, so it needs a very small resistance, but it is not completely zero. Otherwise the protection resistor is also very easy to damage. With your current knowledge is difficult to understand. So then tell you later. Through its quasi-two ends. Through the resistance to reach the real second level. This is XS Max. Someone who doesn't understand the circuit will say they can't find the second end. After you understand the complete detection circuit of voltage detection, including current detection, to check whether the electricity from the charging IC is stable. This is very critical. It detects that there is a problem with the circuit. The phone does not turn on, and various phenomena are possible. Be sure to remember the name of the resistor R3303. Click the F2 pin of the charging IC. It is actually next to it. There are a lot of people who will get stuck here and can't find it. And those who clicked on the iPhone 8 before are all red. But you will find a problem. There is no more in it. Just so few now. It's not like before. Like Flash IC, Fingerprint Boost, NFC, Wireless Charging IC. None. Doesn't it mean it doesn't have these at all? It has a resistor R3303. You will find that the ones we just said are all here. Flash 1, Flash 2. Camera Power Supply IC. Including Infrared Power Supply IC. Front Earpiece IC. Including Bottom Speaker IC. Vibration IC. There is the main power supply, including some middle frame test points. It is also an important component. Look at AU_5G_L_W, Wi-Fi front-end module under the board. When it comes to XS Max, it is Wi-Fi 6, and the Wi-Fi module has one more product. The Wi-Fi module is rarely damaged, but there will be. And this U_5G_U_W is the chip and its front-end module. It will cause weak Wi-Fi signal. Also includes wireless charging IC, touch power supply IC, Wi-Fi module. Amplifier power supply IC, big audio IC, baseband power supply. I have basically found the second end product. You will find that there is no high frequency in the second end of XS Max. Will it be at the third end? Let's find it together. The third end chip is here. It goes to the DC _to DC voltage conversion tube inside. U6150 is rarely damaged. So I want to talk about these capacitors. There are also some third end chips B3, B4. Now summarize the third end of XS Max.